In this section, we're gonna talk about related rate problem. The idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity. I'm gonna begin by doing one example first before I'm gonna explain more on this one. The example say that you have air being pumped into a spherical balloon. So you have air is being pumped into a spherical balloon so that its volume increases at the rate of 100 cubic centimeter per second. So you'll be able to measure this one because what? Because you know how much air you pump into the balloon. Okay, so this one, like I said, you're gonna have the quantity that easily measure. And the question asks you how fast is the radius of the balloon increasing when the diameter is equal to 50 centimeter. Okay, so you like to know how fast, so you're gonna need to know the rate of change in radius. So we need the rate of change, the rate of change for radius okay, so you need the rate of change for radius. So for this problem, the thing that you have to be able to understand will be the quantity that you have, volume and the radius, and you must know the relationship among them. So you know that you have a spherical balloon. So let me draw a spherical balloon for you. So you have a spherical balloon. Okay, I just draw a circle together with some shaded. Okay, so this one will be spherical. And you have the center of this spherical balloon and you have the radius. Okay, so you have this one and you have the radius. So you have the radius r for this spherical balloon. The volume that you have gonna be v equal to pi, not pi, 4 third pi r cube. Okay, so you have the volume equal to 4 third pi r cube. So this one gives you the volume of sphere. Okay, so you know the volume of sphere. And you see that you like to know the rate of change of the radius. So you need to know dr dt. So what is dr dt? It's going to be the change in radius relative to the time t. So in this case, you like to know dr dt equal to what? When the diameter is 50 centimeter. So in this case, you're gonna have equal to 25. So this is the question telling you. So in this case, you're gonna see that we have the relationship between V and R in this form, and we be able to differentiate both sides. So we differentiate with respect to the time t both sides because as the volume increasing, the radius will also be increasing as well. So in this case, you have dv dt. So you would get dv dt equal to 4 third pi, and you have ddt of r cube. So this guy will be 4 third pi 3r square. And don't forget that you use the chain rule. So it's going to be dr dt. Okay, so this is what you have so far. So you have dv dt equal to, so 3 and 3 will cancel each other. So it's going to be 4 pi r square dr dt. Okay, so you have this one, and you know that the air being pumped into the spherical balloon, so the volume increases at the rate 100 cubic centimeter per second. So this will imply that the VDT equal to 100 cubic centimeter per second. So you're gonna plug in 100 into the left hand side. So this one will allow you to compute 100 equal to 4 pi r square, and you know that your r equal to 25. So you're gonna have 25. Okay, so and you like to know r equal to 25. So this one is 25 square, and you're gonna write down the RDT. So in this case, you're gonna have the RDT, okay, equal to, okay, so you have the RDT equal to, you solve for the RDT, right? So you solve for the RDT. So this is the yellow guy that the question asks you to solve. So you have the RE to ET equal to 100 over 4 pi times 25 square. And you will get 1 over 25 pi. Okay, so this one is mean that you have r is increasing at the rate of 1 over 25 pi centimeter per second. So it means that your balloon will increases, so the surface area or anything, so it's gonna be bigger, the radius will be bigger at the rate of 1 over 25 pi centimeter per second if you pump the air into the balloon at the rate of 100 centimeter per second when the radius equal to 25 centimeter. Okay, so this is what this question means. So can you tell me so far what did we do? We read the question. We find the relationship between the variable that the question gives you, and you gonna differentiate implicitly both sides with respect to the time t, okay? And you use the chain rule. So we combine every knowledge that we studied before, okay? So we have the problem strategy as follow. We're going to read the problem carefully. We're going to draw the diagram if possible, like we did here, okay? And we're gonna introduce notation, assign symbols to all quantity that are a function of times. We express the given information and the required rate in terms of derivative with respect to time. Okay, and we write an equation that relate the various quantity of the problem. So this is what we do for v equal to 4/3 pi r cubed, and then you use the chain rule to differentiate both sides of the equation with respect to time t, and we substitute the given information. Okay, so the next one, okay, so for the next one, we have a ladder 10 feet long raised against a vertical wall. Okay, so let me sketch something for you first. So you have a vertical wall. So this one, you have a vertical wall like this one, okay? And you're gonna have this guy, okay? And you have a ladder that has 10 feet long. So it's gonna be 10 feet long like this, okay? So this one is my ladder. So this one is 10 feet. If the bottom of the ladder slide away from the wall at the rate of 1 feet per second, so if you have this guy sliding away from the wall, so what is gonna look like? It's gonna look like you have the ladder slide away. So it's gonna be this one. Okay, so you select this one away at the rate of 1 feet per second. So what does it mean? It means you're gonna have to have variable first. So this one I'm gonna use x and y. Okay, x will be the height here and y will be the width here. So in this case, y gonna go to this direction because of the bottom of the ladder. So the foot of the ladder is moving out. So this guy is going in this direction, right? So the top of the ladder turned out to be going down. So in this case, the direction of x turned out to be coming down. Okay. And you have the relationship between x and y also. You see that the x and the y in the picture. Okay, so this one is the right triangle. So in this case, you know that x square plus y square must be 10 square from Pythagorean theorem. Okay, and you know, okay, so the relationship, and you know that dy dt equal to 1 feet per second. Okay, the question asks you what? The question asks you, let me highlight first. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is at 6 feet from the floor, from the wall? So the question asks, okay, so we have asked dx dt equal to what when the bottom of the ladder is 6 feet from the wall. So you like to know the xdt when y equal to 6. Okay, so we're gonna have y equal to 6. So we solve for x first. So first we solve for x. So for x, when y equal to 6, we have so you get x squared plus 6 square equal to 10 square. So it's going to be x square equal to 100 minus 36. So it's going to be 64. So you get x equal to 8 feet. Okay. So we're not going to say x equal to plus minus 8 because x is positive. Okay. So x positive. Okay. So you have x equal to 8. And we know the relationship x squared plus y squared equal to 10. Okay, and we're gonna differentiate this guy both sides. So you have the dt. Okay, it's going to be with respect to the time t. So you differentiate this guy, you're gonna differentiate term by term. So differentiate to the whole thing here. This one is 10 square, sorry. So you differentiate this guy, you're gonna get 2x dx dt plus 2y dy dt equal to 0. Okay, and you have x equal to 8, y equal to 6. So you put x equal to 8, y equal to 6, and dy dt that the question gives you is 1. Okay, so in this case, we be able to solve for the x dt that we asking for. Okay, so let me highlight the yellow guy. So we are asked for the yellow guy. So you're gonna have the x dt. So it's gonna be 2 times a times dx dt plus 2 times 6 dy dt is 1 equal to 0. Okay, and you get and you're gonna get 16. Okay, and you're gonna get 16 equal to dx dt multiplied with dx dt. Okay, and this one turned out to be equal to negative 12. Okay, so you have dx dt equal to negative 12 over 16 equal to negative 3/4 feet per second. Why do we have negative sign? We do have negative sign because the direction of the the direction is gonna come down. The height turn out to be decreasing. Okay, so this one telling you that it's decreasing because of the top of the ladder is coming down, so the height will be decreasing. So in this case, you can conclude that it's sliding down at the rate 3/4 feet per second. Okay, so it's sliding down at the rate of 3/4 feet per second. Okay, so this one is all of the thing that we have here. Okay, so you see it's gonna turn out to be word problem, and the word problem, the key thing will be you need to be able to understand the question and identify the relationship like this and gathering information that you have from the question. Okay, last one for this guy is gonna be a water tank has the shape of an inverted circular cone with base radius 2 meter and height 4 meter. If water is being pumped into the tank at the rate of 2 meter per minute, find the rate at which the water level is rising when the water is 3 meter deep. Okay, one by one. Okay, so first of all, the thing that you have to draw a picture will be you need to draw inverted circular cone. Inverted circular cone will be the cone that inverted. So it's gonna look like this one. So you're gonna have this picture. Okay, so you have this guy and you have this one. Okay, and sorry, I don't need this one, so it's gonna be this guy and I'm gonna be this guy. Okay, so it should be like this one and another one. Okay, so this one is an inverted circular cone. Okay, and you have the radius equal to 2 meter. So this one you have the radius equal to 2 meters. So you have here, which is the center of the top of the cone, and this guy is 2 meters. Okay, and the height of the cone is 4 meters. The height of the cone is 4 meters. Okay, so this one will give you the height of the cone is 4 meters. This is what we are having. And we are pouring water into the tank. Okay, so we are pouring water into the tank. Okay, and you see that the water level will come up. Okay, so let me draw the water level here. So the water level will come up like this. Okay, and you see that after you pour the water, so you're gonna have the radius r. Okay, so you have the radius r like this. Okay, and you're gonna have the height of the water equal to h like this. Okay, so in this case you see that so in this case you see that this is the picture that you have. Okay, And the thing that we know is going to be the volume of the water in the cone is V equal to 1/3 pi r square h. Okay, so this one is the volume of the water in the cone. Okay, and another thing that we also know will be we have the relationship between h and r from a similar triangle. So if you see this triangle, so you see this right triangle like this one is right angle, this one is right angle, you see that you're gonna have the ratio between radius and height, and 2 and 4 will be the same because these triangle are similar. Okay, so from the similar triangle, give, okay, the similar triangle give r over h equal to 2 over 4. Okay, so r over h equal to 2 over 4. So in this case, you have r equal to h over 2. Okay, so you have r equal to h over 2. So in this case, you're gonna plug in. So it's gonna be 1/3 pi r square. So it's gonna be h over 2 square, h and v. Why did I plug in for R? Because we like to find the rate of change of the water level. Okay, so this one I'm going to highlight the pink one. So we like to find the rate at which the water level is rising when the water is 3 meter deep. So this thing will ask you to find the HDT. Okay, so we like to know the HDT. Okay, uh, when h equal to 3 meter. Okay, so the question asks you to find uh, the water level. So you like to know the HDT when you have h equal to 3 meter. The question also gives you the water is being pumped into the tank at the rate of 2 cubic meter per minute. So this one is going to be a thing that the question also gives you as well. Okay, so from the green highlight, we know that. Okay, so we also know dvdt equal to 2. Okay, so we know dvdt equal to 2 from the green information. Okay, so we know dvdt equal to 2. So we have everything that we need so far. So let's try to find this one. So we have v equal to 1/3 pi h over 2 square times h. So it's going to be 2. So it's going to be 1/12 pi. So it's going to be pi 12. So it's going to be pi over 12 h to the third. Okay. And you're going to differentiate both sides. So you get dv dt. So it's going to be ud dt both sides. So you get dv dt equal to pi 12. Okay. And you have 3 times h square dh dt. Okay. So that's what we want, right? So we want this guy. Okay, so we want this guy, we want the HDT. So we're gonna plug in everything that we know. So we know dvdt equal to 2. This was what we know. We can cancel. So it's gonna give us 4. So it's gonna be pi quarter on this side. And we also know that h equal to 3 meter. Okay, h square here. So it's gonna be 3 square. Okay, and the thing that we don't know on we're looking for is going to be the HDT. Okay, so you would have the dt equal to 8 over 9 pi minute meter per minute. Okay, so you have 8 over 9 pi meter per minute. Okay, so this is what we have for the HDT that we're looking for. Okay, so that's it for this lecture. So you see that it's gonna be word problem. However, the difficulty turned out to be reading the question, and you have to use like a geometry, the basic geometry for volume, for surface area, for Pythagorean theorem. And you'll be able to do this one. Try to do these exercises. It will help you, and I will give you some homework on this one also. Okay, so this one is called related rate problem. Okay, we're gonna stop here, and we're gonna have another topic on 3.10. It's gonna be about the linear approximation.